In the previous lessons, we learned that a measurement will always include three parts. First, we have the number, the unit, and the chemical that we measure. And we talked about unit has a values of its own based on the prefix like milli and kilo. In this lesson, we are going to focus on the number part. That is, how do we determine the number based on an instrument? First of all, if we look at the number will have two types of digits. The most obvious one is the last digit of a number. Now, the last digit of a number is where that number ends. But most importantly, it is an estimated. So we don't know these values for sure. And then we have the other type of digit, which is the opposite of estimated. That's called certain. So these digits, we know for sure that it is there. And how do we know? It can be proven by the markings or the marks on the instrument. Let's look at some specific examples. Here I have a graduate cylinder, specifically 100 milliliter graduate cylinder. It has two values, 10 and 20. Notice how an instrument doesn't label all the marks on the measurement. Now this graduate cylinder doesn't label all the marks. So we have 10 and 20. The question is, how do we find the values of one increment, especially the smallest one? Let's go back and look at the equation. And here is the equation to determine the values of one increment, specifically the smallest one. That is, we look for two consecutive numbers, okay, and then we take the larger number minus the smaller one divided by the number of increments. And in this example, we have two consecutive numbers, 10 and 20. So the values of our increments is equal to 20 minus 10. And we know from 10 to 20, there are 10 increments. So that is being divided by 10. So give us the values of one increment. That is, we're looking at right here, is equal to 1. So this marks right here must equal to 10, 11, 12, 13, 14, 15. So that must be 15. And if we continue to read, this must be 16, 17, 18. So this is where our reading is. Notice how the reading has a curved shape. And when we read the volumes of a liquid, this is where we are doing the reading, at the meniscus level. So the bottom part of the curve. In this case, if we look at the reading, we know for sure that it's between 17 and 18. So I can say that this measurement must be 17 point something. But it's not 18 because it doesn't pass 18 yet. So I can prove, based on the markings on the instrument, that this must be 17. The question is this right here. This is our estimated digit. And that's how we know that our number ends there. So this has to be between 17 and 18. So we can say that this could be 0.5. That each one of this represents 1. And this is about half of it. So it's 0.5. Now we can say that this could be 17.6 as well. Those are all possible answers. In this case, we don't have the unit that's labeled on this instrument, but I know it is in milliliter. Let's try another problem together. In this case, I have the same graduate cylinder. Notice how we have 40 and 50. So the values of one increment is 50 minus 40 divided by 10, because from here to there is 10. So give us the values of 1 again. And we know for sure that it is at the 50, because this is where we're going to read our measurement at the meniscus level. So we know for sure it is 50. But the question in mark is this. What is the values of this right here? In this case, it is about 50. So this must be 51. So here it is right there. We know it is got to be 0, because between 50 and 51. Or if we say, hey, this is a little bit higher, we can say that this is 50.1. But the answer cannot be just 50, because this 0, we can prove for sure it is right there. So we cannot end our measurement there. We have to end at the estimated digit. Let's try another problem. In this case, I have 60 and 70. So 70 minus 60 divided by 10, because from here to there's 10, give us 1. But now we are reading backward or downward. So notice this is 60. So from here to there is about 5 increments differences. So right here must be 55. So this is 55. This must be 56. And of course this must be 57. So we know for sure that this has to be 56 point something. So again, this is our estimated. In this case, it's between 56 and 57, and this value right here is about 1, and it's half of this right here, so half of 1 is equal to 0.5. Or we can say this is 56.6 as well. Those are all valid answers. In this case, the unit again is milliliter, and the unit will be given to us on the instrument as well. In this case, we just focus on how to determine the number. Again, another common graduate cylinder that we use in chemistry is this 10 milliliter graduate cylinder. In this case, let's look at the values of one increment. Again, we take the values of the larger number, which is 2 minus 1. So 2 and 1 are two consecutive numbers on this instrument, divided by the number of increment. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives us 0.1. So each one of this is equal to 0.1. It's not like 1 on the other problem, so it's 0.1. In this case, our measurement is right here. Okay? And this is our meniscus level. That's where our reading is going to be. So here we have 1. This must be 0.9, 0.8, 0.7, 0.6, and 0.5, and 0.4, and then we have 0.3. So we know for sure that this must be 0 because this is less than 1, and we also know for sure that this is going to be 0.3 something. And lastly, we don't know what's the values that's right there because it's between 0.3 and 0.4. So again, each increment represents 0.1, and this is half of 0.1. That will give us about 0.05. And of course the unit is in milliliter. So this one is a little bit tricky. Let's try another one over here. We have 5 and 6, of course. 6 minus 5 divided by 10 give us 0.1 again. So this must be, since each increment represents 0.1, so this must be 5 still. And this is 5.5 specifically. So this must be 5.6, 5.7, and 5.8. So we know for sure this must be 5.7. But we don't know what is the values of that digit right there. In this case, it is 5.8 right there. And again, it's about half of 0.1, and each one of these increments represents 0.1. So what's half of 0.1? 0.05 again. Or we can say, hey, this is more than half of 0.01. So we can say that this is 0.76. But again, we always end our number based on the estimated digit. Let's try the last one together. Here I have 7 minus 6 divided by 10, because there are 10th increments, and 7 and 6 are two consecutive numbers. So give us 0.1. Since this is 6, all the values down here must be 5 point something. In this case, this is 5.5. So because 6.0 is right there, so this must be 5.9, 5.8, 5.7, and right there must be 5.6, and this must be 5.5. So we know for sure that this is between somewhere between 5.6 or 5.7 or 5.6 and 5.5. So we know for sure it's a 5 there. And we also know that this right there, this marker right there, it has to be above or below that mark. In this case, right on the mark, so it is 5.6. We can prove that looking at this mark right there. But this number is not done because we are not at the estimated digit yet. So we have to show that this is the estimated digit. In this case, it is on the mark of 5.6, so it must be a 0. So our answer is 5.60, not 5.6. Because 6, we can prove it. Therefore, it has to be at the 0. This is where we estimate it.